At this time, I am pleased to introduce Rayvon Fouché, Associate Professor of History and the Director of the American Studies Program at Purdue University. He has authored or edited 3 books exploring multiple intersections and relationships between cultural representation, racial identification, and technological design. Today, he will present a talk titled, "The Machine in the Game, Technology and the Contemporary Evolution of Sport." Please take a moment to silence all electronic devices. Thank you, and enjoy.
Good afternoon, everyone. Thank you for making it out to this session. I'm going to have to help myself from looking this way to see what's going on over there. But as mentioned, my talk is "The Machine in the Game, Technology and the Contemporary Evolution of Sport." And in this series of talks on the doom or dawn of our technological future, actually, I think I fall somewhere in between the middle. I love the world messy. We live in a messy world, and when we think about these 2 binaries or 1 and 0s, I think the world is much more complicated than that. So my talk is going to really situate in that middle space between that doom and dawn, and probably won't talk much about doom or dawn, but really think about how we want to see our technological future to be. So it's a bit of a historical piece, but it's also questioning what it means to think about our technological future. And so to begin, I would like us to think about sporting cultures. When we think about sporting cultures, I see them as having 4 elements. And these 4 elements have a tenuous relationship, often conflicting relationship around the place of technology in sport. So let's begin with the governing institutions, right? Governing institutions from the NASCAR to FIFA to the International Olympic Committee all make decisions around technology, which technology is and is not permissible. And a lot of that discussion is around performance, but it's also around markets. When we think about sporting and governing bodies, they're selling athletic competition. And part of the selling of athletic competition is selling athletic competitions between equally matched bodies and individuals. And publics, are fans, the media, all those groups that consume sport are interested in having the governing bodies maintain this perception of equality, right? Fans like to see good competition, are not necessarily invested in the technology. And when we think about sport governing bodies and the fans and publics, they have this symbiotic relationship where governing institutions are providing a product that the publics like to consume. And they like to consume, in theory, fair, equal, balanced competitions. Vertically, we have competitors and technoscientific actors. They also have a relationship. Technoscientific actors are all those groups, institutions, engineers, designers, those individuals building, making equipment of the game. And right, sport creates a host of really exciting, interesting technoscientific questions. And when we think about sport, in the last 50 years, lots has changed. The athletic bodies, at least at the elite level of sport, the differences have become smaller and smaller. So if you're a competitor, oftentimes the place where you can find the largest advantage against your competitors is in the world of technoscience. And I think about technology and technoscience very broadly: pharmaceuticals, materials, devices, and I'll talk about various different pieces as we move forward. So in thinking about this relationship, they all have this perception that technology is a component of our society, a component of the sporting culture, but in a sense shouldn't override all the activities that happen within the context of sport. So as we've seen over the last 50, 30, 20 years, is that technology is becoming more and more powerful in its impact on the game. And sport governing bodies are becoming much more reactive to discipline, ban, and remove technology from the sport, where you have sport governing bodies and technoscientific actors who are just trying to create really cool stuff. And it gets banned, and competitors trying to win. So there's this interesting dynamic around what we have in our contemporary sporting culture and the dynamics that it creates. So in moving forward to this talk, I'm creating this very kind of simplified XY axis to think about how I'm going to talk about technology and sport. When we think about sport and technology, authenticity is a key component. Purity, authenticity, equal competition is a factor that motivates a lot of the dialogue around technology and sport. So right at the bottom part of the axis, we have undermines authenticity. At the top, we have maintains authenticity. The other part about technology and sport is this internal and external. And when I mean internal and external, I'm talking about its relationship to the body. So the deeper in the body, from say pharmaceuticals to surgical treatments, it's much more hidden. And it's very difficult to discern if one body has a certain treatment or using a certain set of pharmaceuticals. So it's very difficult to determine what technoscientific elements are being used by one individual or the other. External things are the things people strap on their bodies, ride, use, the things outside of the physical body. And ideally, right, the technology should exist at this 0, point on this XY axis, at a point of instrumentality where technoscientific stuff is just infrastructure of the game. It doesn't impact the game. It doesn't shape how people play. It doesn't shape how people interact with sport. So in thinking about this, right, kind of working through this quadrant, we'll start at this bottom corner of the internal and undermines authenticity. Right, here's Eprex, which is erythropoietin, which is a blood-boosting drug, which has been used by multiple different athletes to boost their performance, most notably people like Lance Armstrong, right? Lance used a host of drugs from erythropoietin, testosterone, human growth hormone, the whole collection of drugs to improve his athletic performance. But when we think about that, most people argue that these technoscientific treatments are problematic. They should be banned because they undermine the purity of the game. But when we think about sport and the games we play, what's most important is that athletic competition is not about equality. It's about gaining the largest competitive advantage you can, legally or illegally. And the gray area is very gray within the context of sport and sporting communities and worlds. So what's happened in the recent past is you have sports like cycling, move from cycling to swimming to tennis, cross-country skiing. They're trying to move to a new realm to understand and manage bodies and blood. So what we have here is a printout from the athlete's biological passport, which was created by cycling to control or determine the blood carrying capacity of an athlete. So in endurance sports, particularly running, cycling, others of that nature, they create this network of blood values to determine an athlete's then manipulating their blood. So what happens is, say, governing organizations like the International Olympic Committee have created an understanding that the ways in which you determine if someone is using an illegal substance is direct testing. But over the last 20 years, direct testing, particularly in the context of drugs, has proven very, very ineffective. So the next step was to go to indirect testing, which is very complicated because now we're at the point where they're trying to convince the publics to give up on the direct testing to more indirect testing and move the judgment about the usage of banned substance deeper and deeper into the laboratory. All right, so going back to the quadrants, we'll move up to this other section where we talk about maintains authenticity and internal to the body. When we think about that, we think about surgical treatments, like, well, for instance, ACL repair. Right? When we think about repair, this treatment is to bring the body back to a normal state. Multiple high school girls around the country have blown out their ACLs at very high rates. It's a common injury among athletes. But the idea is that the surgical repair to bring the body back to its normal state is okay. That's not seen as problematic. However, we're moving to other places, right? Ulnar collateral ligament repair, or was more commonly known as Tom and John surgery. People are questioning, is this not just repairing a body to its normal state by taking a ligament from someone's forearm or a cadaver and tightening up your elbow, or is that a form of augmentation? Is it taking the body beyond where it should be in its normal state. And if the idea of repairing or taking the body back to a normal level brings us to people like this. Oscar Pistorius, we'll talk about him outside of his murder trial, but in the mid-2000s, 2005, 6, he was this wonderfully heroic athlete who overcame this W amputation by using these amazingly techno-scientifically created carbon fiber legs. Pistorius trying to talk over him. Pistorius was a very heroic case until he started to run a little bit too fast. And images like this created all kinds of havoc. Right, the midsection jiggling Pistorius is not seen as an elite level athlete. So the perception was that he was running too fast because of his carbon fiber legs. Initially, he was banned from competition, not because of the performance capability of the carbon fiber legs, but the perception that since he didn't have lower limbs, he was having to process less oxygen through his body. So in a sense, he was running with a smaller body, which is a fascinating idea to think about. So it asks big questions about what does it mean to repair and bring the body back to its normal state. Is that a form of augmentation, and does that change how we think about our bodies and understand our bodies? So moving to this other quadrant, this maintains authenticity and is external to the body. We think about techno-scientific practices like instant replay. Various different sports have different ways in which they manage and think about instant replay, but one aspect that people love about instant replay is that it saves the game. It saves the game from poor refereeing, poor officiating, and brings it back to the pure elements that people love about sport. But of course, officiating can be very messy. And we live in this world where there's such a high level of oversight of officiating in athletes. And we move to sports like, say, soccer. So this is the shot from the 2010 World Cup. Frank Lampard puts the goal in seemingly. If we're 50 years ago, this just becomes an artifact of the game where people talk about it endlessly, but at that contemporary moment, it gets replayed. And we have images of how that gets played out in different social and cultural contexts. This is the moment outside the state, out in Bristol, UK, where they watched the goal score, and it didn't happen. And of course, a crowd watching on the big screen, and then they're about to see the replay, and you'll see the reaction to the replay.
Come on! Use this little piece here to score any seat, by the way. We knew it was in. We knew it was in.
So part of what we have here is that thankfully FIFA mostly solved their problem after 4 years of stressing about it. But it raises big questions about how can not just the equipment of the game, but the ways in which we evaluate the game, and particularly the multiple incessant replays that happen within the context of televisual consumption of sport. All right, so I'm going to move down to this last section about thinking about the ways that authenticity is undermined and how it's external to the body, and present a series of examples to think through what it means about living in our techno-scientific future. All right, so let's begin here. So Polara. Polara golf ball was initially designed in the early 70s. The USDA and the Golf Ball Manufacturers Association quickly banned this ball because it said these two organizations believe that it undermined the authenticity and the purity of the game. As you note right here, it changes the game. It's a self-correcting golf ball. You put it on the tee in a certain orientation, you hit it, and it flies straight. So
the setup that we use is a setup to duplicate a high handicap player's slice. In order to achieve that, we take the shoulders of the machine and turn them 7 degrees outside in, and we take the face of the club and open it 4 to 5 degrees.
First, he had the robot hit a tour grade ball.
The machine on average sliced the tour grade, the performance grade, and the distance grade golf balls approximately 90 feet to the right.
The TrackMan ball flight monitor was able to capture the same slice characteristics based on the robot's setup. Next, the Polara Ultimate Straight Ball was placed on the robot's tee with the same setup. The results were obvious. The ball flies straight down the target line, and on TrackMan, the ball flight is low and straight as expected.
What we did...
So, we think about the game of golf, right? It's a fairly simple solution to get a ball to fly straight if you put it in a certain orientation. But, you know, this raises very large questions about like the game itself. Is golf supposed to be inherently difficult? And the skill to be able to play is part of how we should think about the game? Or should we be allowed to use certain techno-scientific objects and elements to make us think about the future of sport and changing how we play and engage the game? Okay, so these are kind of straightforward examples of how this works, but let's move to some messier places where we want to think about tensions around technology and sport and what it means to live in a techno-scientific world. All right, so I'll begin by starting with myself. This is from me about 25 years ago. In my late 80s, early 90s, I was an elite level cyclist. This is also the moment in the early 90s when drugs are starting to enter cycling. Also, we have material science entering cycling in a huge way. So I'm riding one of the first mass production carbon fiber aluminum lug bicycles. This person right here is Chris Petty, my longtime friend and training partner. He's riding a beautifully handmade bicycle that was constructed by this craftsman in Japan. It's amazing. It's heavy though. And at the time, there's a lot of tension around cyclists about the equipment they're using because there's all this movement of carbon fiber, titanium, all these different products. And at the time, this is a phrase that I heard a lot. It's the motor, not the machine. We used to tell ourselves that incessantly to quell our concerns about the potency of technology. We used to tell ourselves that the body can trump all the material science, the designers, all the equipment. And it was a collective lie that we were trying to tell ourselves to push back the power of technology and think differently about how we live in our society. And this phrase is linked back to this guy, Eddie Merckx. Arguably the greatest cyclist ever, multiple-time world champion, multiple-time Tour de France winner. And in 1972, he rides what's called the hour record. How far an individual cyclist can ride around the velodrome, unclear what he's putting in his nostrils, ride around a velodrome in an hour. Merckx rides roughly 49.5 kilometers, about 30.5 miles in an hour in the velodrome. The perception is that Merckx puts the hour record out of reach, so far that no one will conceivably ever break the record again. He's considered to be the perfect physical specimen of a cyclist, and yeah, it's this perfect moment. So everyone was hoping he would ride the hour record. He finally rides the hour record, and this is supposed to be one of the triumphs of his cycling career. So the record lasts for a bit, 12 years in fact, and the record is broken by a cyclist named Francesco Moser riding this. So now, all of a sudden, this is a different kind of machine. Two aerodynamic disc wheels, dropped frontal area for a more aerodynamic position. Then Moser increases his record riding this. And then we begin this techno-scientific arms race about the hour record. You have cyclists like Graham Obi riding this, even further. And then Chris Boardman rides further than anyone has ever ridden with Lotus Engineering designing arguably what is the most aerodynamic bicycle ever created. So what ends up happening, though, is the sport governing body, the UCI of cycling, says the technology has gone too far. We've taken this valued and valid record and made it into pretty much a design or engineering experiment. The bodies don't matter. It's all about the techno science. So what happens is here's a set of the rulings they made. 1996, they meet in Switzerland and decide that the techno science has gone too far and we're going to go back to a pure moment. So they decide to get rid of all the hour records from 72 to 2000 and clear the record books and say that if you'd like to ride the hour record, you need to ride a bicycle just like Eddie Merckx rode in 1972. But of course, the idea that 72 Merckx was riding a very simple, pure bike, a traditional track bike, was a complete fallacy. So Merckx here with his frame builder, Ernesto Conago. Conago, one of the great frame builders of the 20th century, spent time with Merckx. Merckx is riding the most technologically advanced bicycle you could at the time. Merckx's bicycle weighs roughly 10 pounds, replete with titanium, all the kind of lightest metals. So the idea that they're going back to this moment where everything is pure and fine and okay was just an illusion. And I think this is the part I'm trying to get through at the talk. We have these moments where we love the concept of sport being pure and unadulterated by the technological infrastructure, but the technology is so built into sport and what sport is and can be. All right, so moving to a different set of examples. This is Adi Dassler of Adidas fame. Fascinating story with him. His brother Rudy creates Puma. They have a falling out to create Puma. Adi Dassler constructs the track spikes that Jesse Owens runs it with in the 1936 Olympics. So fascinating story with Rudy and Adi. But what happens in the '54 World Cup is that Hungary is the overwhelming favorite. And Adi Dassler has been working on cleats. He's been working on these shoes with, as you can see, removable cleats. Before, heavy waterlogged boots would make athletes struggle. In the final, Hungary is leading kind of hand over fist, just destroying West Germany. But at half, it starts to rain. It starts to pour, actually. And then Adi Dassler unveils these shoes, these boots, these soccer cleats that allow them to have an amazing amount of traction. So right, this is the actual shoe. And as the story goes, West Germany runs roughshod over Hungary. They win the '54 World Cup, and all is well. But when we think about shoes, I'm fascinated by shoes because for me, shoes in an athletic situation make a huge difference. However, very, very few shoes have ever been banned, right? And we have the humorous joke.
Money's gotta be the shoes. Shoes. You sure it's not the shoes?
I'm sure, Morris.
What about the shoes?
No, Morris.
Money's gotta be the shoes.
Besides, I love that commercial, but I mean, the idea is it's making the joke that, of course, it can't be the shoes. It can't be the shoes. It's got to be Jordan. But of course, when we think about the NBA, they've only banned 2 shoes in the history of the NBA. This is one, right? The classic OG1 Jordans. And this one, which I assume most people have probably never seen. This is the Athletic Propulsion Lab Concept 1. So released March 2010, to not much fanfare until the NBA banned it, which when the NBA banned it, it crashed their website and they were struggling for a few days. So here's a drawing from the patent. As you can see, if you look at number 54, it calls it a 4-foot catapult for athletic shoes. So here's the cross-section of the bottom right. It's a spring placed between 2 plastic plates on the forefoot, and the idea is that it allows you to jump higher. So of the 12 participants, I don't know what happened with participant number 9, that all of a sudden he can't jump higher with the APL shoes. He's an anomaly. But the idea is that these shoes are going to transform the game. And I'm interested in these shoes because I think when I watch the NBA or professional basketball, I don't know if you stop LeBron by jumping 2 or 3 inches higher. So it's interesting to think about the tension around what these shoes can and cannot mean. And so the NBA, Stu Jackson at the time says this, October 19th, under league rules, players may not wear any shoes during a game that creates an undue competitive advantage. And I'm fascinated by the language of undue competitive advantage because particularly professional basketball is all about mismatches. It's all about putting athletes in different bodies against smaller bodies. So the idea of mismatching is very strange. But if we're talking about undue competitive advantages, why don't they ban shoes like this? This is a few years old, but this is the Adidas Crazy Light, arguably promoted by Adidas to be the lightest basketball shoe ever produced. So if you're going to ban something that potentially will make you jump higher, maybe you should think about banning a shoe that allows you to, in theory, run faster, run longer without much weight on your feet. So part of it is really thinking about, well, what's at stake for sport governing bodies, right? Did they ban athletic propulsion laboratory shoes because of their NBA's agreement with the major shoe manufacturers, or was it really that they're afraid of them? The APIL 1 shoe was banned by the National Federation of High Schools in late 2010. Then they made it legal to play in 2011. So just interesting kind of dynamics around what it means to think about athletic shoes in sporting competitions. Right, so we have shoes like this. The most recent, the Magista, released for the 2010, the most recent World Cup. And the argument is that the shoe revolutionizes the game, the way people play. So, but maybe not necessarily, but Nike is pushing the boundaries about what shoe technology can and cannot mean. Right, so this is the Vapor Laser Talon that Nike released for the 2013 Combine. And when we think about the Combine does have a material and financial effect for the specific athletes. I mean, the shoe is designed to allow athletes to run as fast as they can on the floor of Lucas Oil Stadium. So the idea that they're creating specific shoes that are designed to give these athletes an advantage is pushing the boundaries. But for the most recent one, Combine, they created this shoe, the Hyper Agility. And watch the clip about it.
Hyper Agility cleat is essentially built to help athletes be faster in agility or directional change, specifically for the 5-10-5 or the shuttle.
1, 2, 3, 4, bounce, good, get out, sink the hips, 5, 6, get out, good, finish right there.
The process that we went through in creating the Hyper Agility was getting a real understanding of what exactly is happening with the athlete's foot and the turf at those critical moments of deceleration, changing direction, and acceleration.
Like last year with the Vapor Laser Talon, this time we also use 3D printing. It's a really powerful tool for us because we can actually create these components, these really complicated parts, in a matter of hours. And so you can imagine how much that accelerates our innovation process. And for us, the faster we can actually iterate and test again, we can make bigger leaps in the benefits that we provide for the athletes.
If you ask the athlete to run as fast as he can to that point and then turn around and come back and you say, look, but I don't want you to start slowing down until you get right up on the turn point. He's going to say, I can't do that. Well, why not? Why can't you do that? Well, because I'm going to overrun. Why are you going to overrun? Because I'm going to slide.
We created this shoe for maximum deceleration by essentially innovating around the geometry of the studs, the shape of the studs, and the placement of those studs. And then the transition is really, in footwear, all about containment and really locking down the foot on this amazing footbed. And the way we did that was through flywire that's actually dynamically continuous throughout the entire 360 forefoot.
There's never been anything made like this before. They've never used any equipment like this before. There's never been equipment that's specifically made for the 5-10-5 drill or for agility. And so this gives them the confidence that, no, now I'm putting on a shoe that is designed specifically for me to optimize my 5-10-5 drill.
So I'm intrigued about the kind of rhetoric that they use, because it's this delicate balance, because you want to promote how effective of a tool this can be, but if you push too far, then it's seen as an unwanted or unwarranted or an unnecessary technological advantage. All right, so when we're thinking about running and athletes, starting has always been an issue. So this is a picture from 1947. There's an individual, Ben Ogden, who is the track and field coach at Temple University, who was interested and fascinated with the idea of, well, false starts. There are too many false starts because it was human-made. The idea that individuals and people would determine how quickly or how slowly an athlete would start a race was problematic. So Ogden was a big horse fan, so he created a device that would, in a sense, lock these athletes into place. And then when the gun would go off, it would release them like a set of horses. Of course, there were a lot of interesting commentary about this at the time. But regardless, it raises very interesting questions about how we think about sport, and particularly track and field, and implementation of new technology. Right, so this is roughly what is used right now at elite level track and field events. You have the electronic gun, you have pressure sensitive foot pads that determine how quickly or slowly an athlete can get off the blocks. And this technology seems to work most of the time. And when we think about that, right, all of a sudden there's this tension, particularly at different levels, between using this technoscientific equipment to determine if an athlete should or should not have a false start. But it comes down to the place of the human referee or judge, right? So it says false start technology is used to support decision making, not making decisions. So this is from the USA Track and Field starter manual. But the IAAF, which is the governing body of track and field, says this: when an IAAF-approved false start control apparatus is in operation, the evidence of the equipment shall normally be accepted as conclusive by the starter. So the argument that, well, the starter, who is the person, in a sense, holding the electronic starting gun, will determine the false start, or if it's a legal start, pretty much it's saying that it's telling the individual to speak on behalf of the technology. So in general, this works most of the time, not all the time, but there's some huge moments where it kind of unravels in very interesting ways.
Set.
So let me kind of back up a second so I can, I'm about to show the little clip of the 2011 finals, 100-meter finals, where Usain Bolt false starts. And according to the rules, any movement of one's body is a false start. So Usain Bolt is in between Walter Dix and Johan Blake, his countryman, and Johan Blake twitches before Usain Bolt false starts. So the idea is that if we're thinking about the eye, the historically eye of looking at whether an athlete false starts or not is the key element in determining a false start, and we move to the technoscientific, we miss certain elements. So,
oh no, the whole crowd will go.
Wow,
because that was Usain Bolt.
Massive, massive disappointment.
So they showed Blake over there twitch a little bit.
That is one of the biggest shocks of all time in a sprint final.
So what would be interesting is, right, this would just become another anecdote in the history of track and field. But since all this equipment is linked up to a set of data tracking devices, you get things like this. You get actually the start data. And according to track and field, a legal start is someone moves 1/10 of a second after the start of the gun. So it's pretty much the green line is the legal start moment. But as you can see on the bottom in lane 6, this is Johan Blake. You see his leg twitch, but he doesn't twitch enough for the the detecting system to detect a movement of false start. So the argument that exploded over the web after this was that, no, Usain Bolt false started because he saw Johann Blake twitch. And if we had the previous world where individual eyes are watching the bodies, it would have been Johann Blake who would have been disqualified. And what ends up happening, Blake goes on to win the world championship and when they run the race again. So there's a lot at stake at these different moments and asking very powerful questions about how much and how far are we allowing and wanting to put technology into the context of our sport. So in finishing up, part of what I was trying to present is we live in this moment where we have this sporting culture that's struggling with the place of technology. We have publics who want to believe that athletes are doing it themselves. We have engineers and designers who are excited about the techno-scientific questions that are being asked and the potential of the equipment that they can make. We have governing bodies constricting and controlling the use of technology to make sure that athletic competition is, and hopefully will only be, about the bodies versus bodies. And then finally, you have the competitors that are deathly silent about all kind of techno-scientific equipment in sport. And I think arguably they're silent because it's an opportunity for them to use their, in a sense, gain the largest competitive advantage that they can. So I think that's really all I have to say. We have about, I think, 7 minutes for questions if people have questions. So I'd like to leave it at that. Thank you. Yes, please.
Where do you see the next big technological change taking place in mainstream sports?
Yeah.
For example, baseball, I've heard that possibly in the future they'll eliminate umpires because strike zone can be laser beams, things like that. Do you ever see it going that far?
Yeah, I mean, I think baseball is very interesting because they already track, they evaluate umpires. They already track the pitches. They already track strikes and balls by umpires officially. So if baseball really wanted to go that way, the technology is already implemented. They could even just, tomorrow, they could just eliminate all the umpires. But of course, they're not going to eliminate the umpires because it's part of the culture and practice of the game. But I think the future is all about material science. I think we're at the place right now where we're starting to get a little traction on that, and it's really pushing the world in different ways. You know, probably about 15 years ago, there was a group at, I believe, Texas A&M who were in the ag school who were trying to genetically engineer trees, wooden trees, to perform in the similar way of an aluminum bat, give it a different trampoline effect. So, you know, that was kind of the undercurrent, and I don't know that there are many people going that direction, trying to use natural materials and having them perform differently than they would historically. But from my perspective, it's in the mainstream sports. It's about material science. It's about lightness. It's about fabrics, and that's where I see really big changes coming. And it's going to change how people play, how people work together. I think there's a lot of interesting things going on, particularly in football, helmet design and technology. Concussions have been very on everyone's mind, from youth soccer, football, baseball. I think that's a really kind of key area. But for me, I see it being lightness and efficiency. But I think that the next wrinkle are electronics. In other places there have been the whole world of wearable technologies, and the wearable technologies haven't really taken off in the context of the sporting environment. Yeah, go ahead.
So, all of the electronics and wearable technologies, some of the powerful things they can do is collect data. And data is very expensive, and even in the future, possibly that some people will have access to this. How do you think that will shape up the competitive sport?
Yeah, I mean, I think not only kind of data analytics, but from people wearing their Fitbit band, I mean, I think potentially I can see it going to the direction of really monitoring athletes on a daily basis, right? And I brought up the athlete biological passport. Ideally, when they initially started talking about using blood values, they went into the extreme things people were saying is that they were interested in tracking babies. So they were going to start that early on because, right, you know, people can start manipulating their blood values at a certain moment, but if you start when everyone was born and, you know, the world of bioinformatics is kind of replete, so we can figure out how to track them. But yeah, I think there's going to potentially be a very powerful perception about the use of data. Automobile racing has been very, very good at using data. Some of those sports have not been so good at using data. So, and I think data-connected performance, actually physical performance, right? Baseball, sabermetrics has been really great at using data to see if, you know, strikes versus balls versus fielding aspects. But, you know, I think potentially going to the next process of, you know, chipping bodies and seeing specific performances.
You brought up the NASCAR about that, so a little bit of follow-up is anybody looking at limiting the technology? Because in NASCAR, for instance, a team with less funding cannot conceivably win a race outside of fluke type things happening. So a runner, you know, in Ethiopia, will they still be the marathon runners? Or will they just not have the money to compete against Americans, for instance?
Yeah, you know, I mean, I think this is I think that's a very interesting question, right? Because particularly for NASCAR, they went to the car of tomorrow to, in a sense, make the field equal and decrease the expense of racing at that level. Formula One is trying to do similar things. MotoGP is going with trying to move away from the factory motorcycles. But, you know, I still think there's people that are, I mean, my feeling is that sport has always been about bending and breaking the rules. So the idea is when you can set a set of constraints around technology, that just fires up the engineers more to be more creative and innovative and work around the existing parameters. So, I mean, I think expenses always be a problem, but I hope that creative ideas will conceivably trump the dollars. All right, as I look up at the clock behind us, it's 2:44. So thank you all for coming, and I hope you enjoy the rest of your afternoon.